Hi my friends, today we model this hyperboloid drawing mechanism, and you can see that the whole palette can be adjusted to achieve unique results as you like. This is the model with some components, all of them aligned here in the browser. In order to have both the image and the names, you see the components and the assembly. Let's start. New, standard millimeters IM, place, central shaft, grounded at origin. The position is from Inventor 2014, and we select another position. You see, this is the axis X, and we fix this as a current view as home. I like to use edges in order to have a better presentation. Then we add the other components. Place the adjustable stand, 1, 2 parts, and also this multi-hole plate. These are the main objects. I apply constraint to place this face on this face. Apply. Then I move a little this part because I want to place this side here. Apply. This degree of freedom translation is still unconstrained. To constrain it, I don't use insert between these two because I don't want to have an over-constrained situation. And I apply coincidence of this point with the central shaft plane. Let me see better. This plane. Yes, you see connection. How many degrees are now taken? All 6, and this last one is only 1 degree of freedom taken. Apply. Good. The other pair of that object goes on this face. Apply. And it is parallel with its side with the other part. Okay. What degrees are here? The same like before, this point with this plane. Apply. This is a free degree because we use this plate with holes to connect the two parts. To obtain that connection, we add some components. Place threaded rod, this one and the other one, and we place it, constraint. This time we use insert to these two circle axis. This is so, and the other comes here. Also insert here. Okay. Then we place this end here, constraint this end at a distance of 10 from this face, but with a line and with minus to be okay. Apply. We can move this, but let me place the other with the flush option between this and this plane. Now we take more than 1 degree of freedom, but nothing is critical. I have to place this at the center of this channel. I apply the distance of 10 between these two, a plane and an axis, because I know the value. The value is 10 with minus. Okay. Good. You see? Now I can make the same constraint between this axis and this face, also 10. With minus again. Okay. We constrain the two components threaded rod by using the distance from the axis to that plane of 120 for both on the two sides. That plane was this one. This is with minus. Apply. And the other the same but with plus. $120. Okay. Now we have a fully constrained combination. You see, these points shows fully constrained parts in position. We can verify this by using view and degrees of freedom. You see, nothing appear here. To be sure of this, I apply, for instance, suppress this mate. And now we have freedom. You see? Unsuppress, and we go back to full constraint. At this moment we can start with dynamic simulation, but I want to add the other components. Place 2 pins, 1, 2, they are constrainable on their axis. Apply. And apply. We know that each pin has the center point in the middle. I select this and I want to show you where is the center point. You see, it is in the middle. So we can apply constraint of this point to be placed on this axis. Yes, apply. The other one, which is this one, center point placed on this axis. Okay. We continue with other components. This is another component. One is here, one is here. Constraint, insert this circle axis, come here, apply. The other one, same, apply. Now we place 1, 2, 3, 4, 5, 6 pairs of nut and washer, of nut and washer. This is the nut. 1, 2, 3, 4, 5, 6. And washer, this one. 1, 2, 3, 4, 5, 6. We combine them one by one with their axis in common. Not with insert, cancel. I apply insert to each one, apply. You see, it doesn't matter if I select this circle or this circle. They must be on this face. Apply. This circle or this circle, but not the inside one. I hope you know this. Then I place them on their axis with mate. This axis comes here. And this face, apply. On this face, apply. Another one is this one. On this axis, and with its face on this face, apply. The other come reverted, so I have to start with face first. You see, here is this one, apply. Then the axis, apply. This face goes on this face, apply. You see this is the one, and the axis on this axis, apply. The face, on this face, apply, and the axis with this, apply. The last one goes here on this face, apply, and the axis on the axis. Okay, now I finished with this. Now we have to eliminate this grounded part because it will be rotated. I eliminate this, but I must place something instead. I place constraint between the axis of this and the axis of X on the assembly. Apply, and I also apply, this is central shaft, and I select its center point to be placed on the same axis. On the center point of the system. Okay, now we can rotate this about that axis. Now we can apply dynamic simulation. You see here there are no one grounded and all the other mobile. We apply a torque in order to create the movement. Now we don't have any movement. Torque on this location, and Inventor waits for an axis, and this is the axis. I apply here 0.4 Newton millimeters. Okay, and I try to see if something happens. You see, there was a small movement. I have to change the direction there, so I go to torque, double click, and the other direction. Okay, I change also this with 5 seconds. And you see the movement. Good. What about the circles to create the hyperboloid? Well, we apply trace to each hole. This will be black. Apply. If I start movement, you see that this is created. Stop. Go back. Then I go to another trace, but with another color. I select this color and I use red. Where? Here. Apply, cancel, start. You see the color red is now created. Good. I'll continue with adding all the other holes and I'll show you what happens. I place traces to all that holes and take a look what happens. The duration is 1365 to have a full circle. Start. You see, I selected a lot of colors, and I want you to know that all the holes are on the same line. What means this? It means that if I rotate a line about a non-coincident axis, we obtain a hyperboloid with one face. Do you see? It's great. All these points are aligned and together they create the hyperboloid. As you can see, a line in rotation about an axis creates this marvelous surface. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have two options. One, to contemplate what I do and apply my actions by creating your own components of this assembly. And two, try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must own the component. That is, they must be yours. As separate creations that I made for the purpose of showing practical aspects in the tutorial, you can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones include the previous ones. That's all for today. Thanks for watching. Bye bye.